My name is Tim. I'm from the Gardener core team at SAP, and I have been working on the Terraformer V2 over the past few months, or especially the last few weeks more intensively. And I want to basically share a quick story on how this went and how this looks like at the moment. I don't plan on showing many slides. This is just to give you a bit of context for those who don't have it yet. And then I want to jump straight into the live demo. Okay, so this presentation is basically about this pull request. It's the main outcome of the topic. We will see it later, what it's actually about, but just to get one step back, what is the Terraformer? So if we remember this flowchart, it's basically composed of the most important steps that Gardener executes in order to get to a fully functioning shoot cluster for its end user. And one of the important steps, or at least one of the first steps also, is to create this infrastructure custom resource. It's basically about preparing the infrastructure for workers, nodes, and so on. And this mostly means creating a VPC, some subnets on security groups or whatever. So basically everything that is created on the infrastructure in order to place worker nodes in the end user's account. So how does this look like on the seed cluster? So when a shoot cluster is created, the first step is always to create a namespace on the seed cluster, which will host the control plane and so on. As said, we need some VPC and subnets and so on the infrastructure layer. And because the gardenlet doesn't know anything about the provider specifics and is basically pretty generic, it just creates this infrastructure custom resource in the shoot namespace, which is basically an intent to create those resources needed for a specific provider. And then the responsible provider controller kicks in. It's basically notified about this new infrastructure resource. And then it is responsible for creating all the resources that we need. So this is basically how this extension contract around the infrastructure looks like. But Gardener doesn't specify how to get to those infrastructure resources. It basically just states what the end user wants. So for example, which sitters to use for the subnets and so on, which region to place the VPC in. But it doesn't specify how the provider should create those resources. So one straightforward approach would be, or maybe not straightforward, but one obvious approach would be to use the native Go SDKs in the provider controller to create those resources. But for simplicity reasons and legacy reasons, many of our provider extensions actually don't do this directly via the Go SDKs, but leverage Terraform. And for this, we have Terraformer, which is basically a wrapper around Terraform and is basically a small Docker image or a simple Docker image, which can execute Terraform commands with a given configuration inside a pod. So some of our provider extensions like AWS and GCP create this Terraformer pod in the shoot namespace, and this in turn will then create all of the needed infrastructure resources. So now you basically have this basic picture of how Terraformer is instructed. It is basically sitting in this repository under our Gardener org. So what's the problem with it? Why did we have to rewrite this whole thing? I mean, the problem basically lays down in those lower two files here. You see those are scripts which basically just call Terraform. And yeah, if you look at this, you will see this code, for example, which updates the state config map. So if you know Terraform, it keeps the state of the infrastructure resources that it created in a file. And the Terraformer basically pushes this file or the contents of it to the state config map. So we can basically destroy the infrastructure later on if we want to delete the shoot cluster. And this is pretty important for us, so we can basically keep track of all the resources we created and have to clean up later on. So you see this bash code is a bit messy, and yes, this is used in production. We basically have no unit tests for it, and yeah, it's a bit hard to maintain, I would say, and we don't have such good output qualification for it. Yeah, and that's why we ran into several problems with this approach. One time there was an AWS outage, so the IAM API wasn't available for a certain period of time. And because we only update the state config map in this shell script at the end of the execution, all our Terraformer pods ran into a timeout. They tried to stop Terraform, but it didn't. And then they didn't update the state config map. And that's why we leaked many resources. Yeah, so one problem is basically that we can't really properly handle signals, or we have at least seen some problems with it. And also we basically sometimes lose this important Terraform state. And that's why we decided to do something about it, which is basically this issue here. So we said we want to rewrite Terraformer, and basically replace it by a golang program. So this golang program should basically just delegate all the Terraform commands to a Terraformer process, just like before. And additionally to that, it should basically watch this Terraform state file and continuously update the state config map as soon as this file changes. And it should also delegate any signals to the running Terraformer process. And that's basically how we came to this pull request, which I have been working on over the past few months. This implements this Golang wrapper. So now this looks a bit different. As you see, it's completely written in Go. And here you have the most important logic of this Golang wrapper. And the most interesting part about this rewrite is actually this file watcher. So it watches the state file and gets notified in a separate worker routine that the file was changed. And as soon as that happens, it directly updates the state config map. So we don't lose any important infrastructure state anymore. And yeah, this is really nice. Okay, so without further talking, let's jump into the live demo. What I have here is our provider for GCP. which contains also a small integration test, which basically creates this infrastructure custom resource, which I was talking about. And GCP is leveraging Terraformer for it. And I'm going to run this infrastructure integration test now here. This will deploy the Terraformer pod to a namespace on my kind cluster, which is running on my laptop here. We see it created this namespace and also the Terraformer pod in it. And if we keep a watch on the state config map, we will see that it will be updated along Terraform's operations. So here we have the log of the Terraformer. We see it's still working. I have enabled the debug log so we can see that it gets notified about the file changes, like for example, just now, and boom, there you go, the state config map was updated. So this basically allows us to really have the complete state in track on our Kubernetes cluster, so we don't lose any important state. Yeah, and this will run for a few more seconds, I guess. It takes some time to create all the necessary resources, but we should see in a few seconds that this will complete successfully. And then the infrastructure integration test will go on and just delete the infrastructure resource again. And then the GCP extension will kick in again and delete the resources via the Terraform destroy pod, which was which will probably be deployed in a moment. Yeah, there we go. We see the Terraform destroy pod. We can open the logs again so we can follow it. Yeah, there we go. And you will see that the resources on the right side will disappear from the state as soon as they were deleted on the infrastructure. And now I think you get the main principle of this, and we can expect the test to finish successfully. So I will jump back to the slides. That was it for the live demo. So what's the current status about this work stream? Yesterday, I implemented also a small integration test for Terraformer itself. So a standalone integration test if you want. This just creates some lightweight resource on AWS and checks that the config map for the state was properly updated and everything works as expected. And Terraformer itself does all the right things. This is still ongoing. There's some configuration missing for it so that we can always execute this test on pull requests for the Terraformer itself. And there are some other small tasks left, which I have to complete before we can release this new version. But as soon as this happens, or maybe even before with the release candidate, we want to use this new Terraformer version in our provider GCP. So we can get some first experience with it, run it on our internal development landscapes and execute all the automated tests. So we can observe it for a while. And then we want to roll that out on our internal productive landscapes. And if we don't see any further issues with it and everything is working fine, then we, of course, also want to use the new version in the other extensions that use Terraform for the infrastructure reconciliation. Yeah, and that's basically it from my presentation. If you have any questions, feel free to ask them now.
Yes, I have one question about the state file. So the state file is inside the pod, a local file, right?
Yes.
Yeah, does this make sense, or is it not better to have an that we use S3 or something like this, that we have it not inside the pod as a local file?
Yeah, I mean, using S3 or some other storage backend would also be possible, but we actually chose to have the state in this config map, which I just showed. So we have basically everything in the Kubernetes cluster and completely under our control. And one advantage is, of course, that this always works as long as you have a seed cluster available, which you have to have available, of course, for your Gardener installation, and you don't depend on any external service, I would say.
And it happens anyways. So Gardener is 100% Kubernetes native. So of course, all the resources Gardener manipulates are in our clusters, and the clusters themselves have continuous backups that are running. So the moment this ends up in etcd, it anyways gets incrementally backed up, and the backup is the blob store that you have chosen. So it anyways ends up in S3 rather quickly.
Yeah, makes sense to me.
I have seen that Terraform have a Kubernetes storage backend, I think. Was it possible to be used, or does it have some disadvantages?
That's a good question. I think Martin Vladev also proposed to use this one. I actually haven't tried it out, but it looks like this would have also been possible to use, yes. But we decided to go for this approach with the file watcher and so on, because then we have basically full control over the storing mechanisms and so on. And we have encountered some issues with some Terraform plugins in the past. So we don't want to rely on another component which could have bugs. So that's basically why we decided to do it this way.
Thanks.
Just one more question, Kevin here. So when the Terraformer basically provisions the infrastructure, the TFTL is basically added, and then after that, if you, as a config map, and when the config map changes, you do a reconcile once more?
No, the reconciliation is only triggered by the Gardenlet itself. So, for example, when the infrastructure is created or deleted, obviously, but our extension controllers are instructed to basically only do reconciliations when the Gardenlet specifies to do it via an annotation. And this way we have full control over when the reconciliation is supposed to happen. So for example, if the end user specifies that their shoot cluster should only be reconciled during midnight and 1 a.m., then also the infrastructure resource will only be reconciled in this time frame, except the user updates the shoot, obviously.
Okay, thanks.